Recording has begun. So what will happen? Two bodies will approach towards each other and a force will come into play for a short but finite time. Obviously the time is short time, but it is finite. What will happen after that? There will be measurable changes in velocity, momentum, and energy of the bodies governed by conservation laws. So that is what collision is. That is when two bodies will approach towards each other and a force will act for some time, which will result in some changes which we can measure. That is some parameter of mechanics like velocity, linear momentum, and energy. And how they will change, that would be taken care of keeping in mind the conservation laws. That is conservation principle of energy, conservation principle of linear momentum, conservation principle of mass. Okay. So that is what collision is. Yeah, and this thing may happen when they are in contact. That may also happen. So contact is not mandatory. Again, contact, better to say physical contact. So physical contact is not mandatory. So you have seen that picture that I shared. Let me redraw it. So what happens before the collision? Say I have a body of mass m1 which is moving in this line, the velocity v1. There is another body of mass m2 moving with the velocity v2. And as you can see, the direction of the velocities tell us that they are bound to meet each other. I mean, if not collision, but they are approaching towards each other, isn't it? Now, what will happen during collision? I'm drawing the general case, okay, where contact is not mandatory. So, what will happen after during collision? This body will be deflected. It was supposed to move in this direction if there were no other bodies, and this body was supposed to move along this direction under similar circumstances. It will also be deflected. You can draw analogy to this using two magnets. However, that's not collision. That's a different thing. As if when two magnets are brought together, if they have opposite polarity facing each other, they will repel. Kind of that. But magnetism is not collision. So one thing is clear. If you look into this picture and this picture, you will understand that something has occurred here that has tended to change their paths. And what will happen after collision? Again, let me trace the initial path of both after collision. Both the bodies will now set out, but with a different velocity different from the previous one. That is, previously the velocity is where V1 and V2 respectively. Now they are V1 dash and V2 dash respectively. So this is a general picture of collision. Yeah, you may draw it like this. We'll in fact study those cases where bodies will be in contact. Those cases definitely happen. In games of billiards, snooker, carom, you can easily understand that these things happen. I mean, contact happens, and they change their direction. So, what is that example where there is no physical contact but we are claiming collision? That is no physical contact. However, this type of collision doesn't exist. I can still name it like that. Okay. There is no category of collision called no physical contact type. But an example of this kind of collision can be the scattering alpha particles. If you don't remember this, you can study this Rutherford Goldfall experiment, which Rutherford uh, performed to get a deeper insight into the structure of an atom. And in an experiment, a very minuscule fraction of alpha particles detrace. That is, they were supposed to go this way, they were sent this way, but they were caught in the detector in this direction. That is, as if they are being collided from somewhere, like a ball hitting the wall and bouncing back. Okay, it was concluded that collided with the nucleus. That's a different story. So that is an example of collision without any contact. Okay, so if your brain is still accommodating collision with contact, don't try to remove that. Try to assimilate the fact that collision and contact is not the mandatory condition for collision. What is the mandatory condition? Yeah, this changes in, yeah, they should approach each other and there will be a change in velocities, the velocities of the bodies. Is it clear, everyone? Any doubt, any queries? Fine. Now, so then what are the types of collisions? So, no. So the collision will have to be taken care of when there is a change in that momentum energy. That is not collision actually. That is just deflection due to a field. When you are keeping a charged particle in a field, it is getting deflected. That is not collision. Okay. Because magnetic field has a peculiar property, it doesn't change the velocity, it just changes the path. Magnetic field has only one effect, to change the path of the particle. I said that you can think it is analogous to that. Okay, but it is not exactly that. And the collisions will always require two particles or bodies. Okay. Anyways, collisions are of three types: elastic collision, inelastic collision, and reaction. Okay, so we have three types of collisions that we have to study. Mainly elastic and inelastic will do. Um, I don't think there is much to study regarding reaction. So how to define them? It's up to you. But physics stands for precise. I won't use a lot of words to describe them. Rather, I would uh, try to use a table so that we can easily distinguish between differentiate these three from each other. So we have elastic collisions, we have inelastic collision, we have reaction. Okay, this elastic collision has nothing to do with elasticity, however, don't get confused. Elastic collision, inelastic collision, and reaction. Don't use the word collision after reaction, okay? So when we distinguish between types of collision, mainly there are two parameters, the particles involved and their kinetic energies. Okay, so in elastic collision, the particles before and after are same. Particles before and after collision, they are same. And kinetic energy of the particles is also same. Peaceful negotiation, everything is same. In elastic collision, particles before and after collision are the same. However, their kinetic energies become different. And reaction is that same reaction, the chemical reaction which was studied in chemistry. The definition says that what? When two or more substances are brought in contact, new substances are formed. So particles before and after are different. Definitely, this thing is also more probable. That is how we can distinguish among the three parts. Now, one thing may come to your mind that, sir, if energy is different, is there any violation of energy? I mean, loss of energy or energy is getting lost or created. So, one thing keep in mind that in all cases, total energy is conserved. I think you need not to be explain this thing. It's been a long time since you have been reading this thing in physics and chemistry. Okay, that collision energy before collision and energy before collision, if, after collision, if they are different, that doesn't mean the energy conservation principle is violated. We'll see where that energy is being used. Let us see if we can give an explanation to that. So is everyone clear with the difference between these three? Clear, everyone? And in your syllabus, there is only elastic and inelastic collision. Reactions are not there. But if you are curious, you can study on your own, no problem. If you require any help, I can try to help you. So let's begin with elastic collision. So whenever we are writing a collision mathematically, we'll be basically writing two things. First, related to something related to momentum, linear momentum. Secondly, something related to kinetic energy because they are in motion. So for linear momentum, what I can write, say two bodies of mass m1, m2 were moving with velocities u1, u2 before collision, and after the collision, sorry, masses are same, the velocities have become different. Difference can be either maybe the magnitude is same, direction is different, that is also different velocity, or the other way around, or both. Anyways, the velocity has become different. So what is the total momentum?
Sir,
Yes,
sir, can you shift the copy a little bit to the left?
I mean
It
towards
is not
linear
visible.
momentum.
Yes, sir.
Okay. Now is it okay?
Mhm. Now it's
Fine. So the total linear momentum before collision is simply the product of individual momenta, I mean the vector product, and total linear momentum after collision, they are equal. I can write this only for elastic collision. And what about the kinetic energies? No doubt that. So this is about the kinetic energies. So the main issue is that not linear momentum. However, if there is no external force acting on the system, then that has to be conserved. We read this thing, isn't it? This conservation principle is valid for both the react collisions uh, if there is no external force acting on the body, if the body is isolated. However, this thing I cannot write this equal to this for inelastic collision. That is for inelastic collision. Am I audible? Is there any noise in the background?
no, sir.
Okay, fine. So for inelastic collision, these two energies are different. That is energy before collision, energy after collision are not exactly equal. One case can be energy before collision is less than that after collision. Okay, where Q is called the excitation energy. And this thing can be for macroscopic bodies. You can understand when there is any collision or anything, sound energy may be produced, there may be light produced, and there may be heat. Heat is definitely produced in most of the cases. And what happens in the microscopic world? Atoms, maybe some atom has, if atoms gain energy, they will be they will jump to the higher energy level. So these kind of things where there is uh, energy towards the right, it would be called endoergic collision. Endoergic collision. They may be asking you this in the exam. And if the opposite happens, oh, okay, let's tell him to keep on trying to log in. Class will continue. I can understand network issues. No problem. So you can join later. And this case would be called exoergic collision. Okay, I'll just look into these two things. I don't know why I'm feeling that the definition in the book is reversed. I'll have to check. Okay, whether this is exoergic or this is endoergic. I'll have to check. It is like that endothermic exothermic reactions. Okay, if heat is produced, it is exothermic. If heat is absorbed, it is endothermic. I'll just check it. Okay, I'll just let you know in the group. Anyways, so this is the situation for inelastic collision. There is a inequality of energies, and as far as you can uh, account for that, why where that energy is going or coming from, is perfect. So now in the in this chapter, we will study collisions mainly in 2D and 1D case. One dimension, two dimension. Okay, three-dimensional case is very difficult to handle. You'll understand it once you get done and dusted with 2D case. Okay, that is we'll first study, say, elastic collision in one-dimensional case. That is, the motion is only along a straight line, or only along one direction. Okay, so what are we assuming? We're assuming that we have two masses m1, m2 moving with velocities u1, u2 in a straight line, say towards right. You can do towards left also, no problem. So m1 is moving with u1, m2 is moving with u2. You can take this velocity on the opposite direction as well. Doesn't matter. If two bodies are moving along the same direction, they may also collide. So, and let us assume that u1 is more than u2. This assumption we can make. And suppose they are having a head-on collision. That is direct contact, head-on collision. I am not drawing the picture. If you want to draw, it is nothing. It is just the two bodies in contact. What happens after that? After that, what will happen? They are moving with different velocities. Same one will now move with v1 velocity, and m2 will be moving with v2 velocity. And this picture is a bit difficult to draw. Okay, you don't know whether which particle will go ahead, which will go backwards. In A.B. Gupta's book, they haven't drawn the picture. Okay, but it may be like this: like two runners are running in a lane, in a straight line, they collide with each other, and maybe they don't fall. What is happening? They are moving with different velocities now compared to the situation before collision. And the good thing is that if all the collisions, if all the velocities are along the same direction, we need not to put this vector sign. Why? Because each and every velocity vector will have the same unit vector. If I take this one as the x-axis, then u1 can be written as u1 I cap, u2 can be also written as u2 I cap, v1 can be written as v1 I cap, v2 can be written as v2 I cap. So if there is a equation consisting of all these velocities, I need not to write the velocity vector. I mean, I need not to put the vector sign above them. Okay, that is, I can write the condition for linear momentum conservation now, assuming that the system is isolated, there is no other influence on it. Then what is the momentum before collision? First, let me write with the vector signs, then you can understand what I am trying to say. Now see, each and every velocity term will have an I cap in common. So I can easily write it like this. Got it? Why I could write them as scalars, not vectors. Did you get it?
Yes, sir.
So this is the advantage of using 1D case. And if you are very good in just breaking down complicated cases into 1D cases, that is, if you are very good in understanding the direction, then also you can write the things without vector sign. Just if anything is opposite to that direction, it would be minus. Anyways, let me take all the M1 things on one side. So I can call this my equation 1. All the M1 terms on the left, M2 terms to the right. Now, the most important thing, or the more important thing, the energy conservation. So, what about the kinetic energy thing? Half, that is kinetic energy before collision, should be equal to kinetic energy of sum of kinetic energies after collision. Absolutely nothing to worry about vector, isn't it? Kinetic energy is a scalar quantity. Oh, by the way, did everyone register for tomorrow's webinar? Is everyone registered? Okay, each and everyone must be there. It's compulsory to be there, and I must say you all are lucky that even in these circumstances, our college is organizing webinar in regular intervals. Okay, and slowly you people can also uh, be active in those things. Like a webinar has many dimensions. We have to design the that flyer, that is the brochure, not brochure, I mean that template kind of thing, uh, certificate designing. Okay, so in the future you may also help us with that, and when you go to some other level of your education or your job, you will be benefited with these skills. So please be ready for tomorrow. Make yourself free after 11:30 tomorrow. Anyways, you can see that there is half in all the four terms. I can cancel the halves. In the next line, I won't write the half. and then I will do the same thing. I will take all the m1 terms to the left, m2 to the right. So I can call this equation 2. Now, please tell me what you think I'm trying to do. I mean, why am I making the equations like this? What is my intention? Can anyone get it? Can anyone guess what I am trying to do exactly, or what I am trying to find? Anyone? What do you think I would be doing next with the equations? Equation number 2 and 1. Will I add them, subtract them, divide them, or multiply them? Yeah, Swarup is correct. I'm trying to relate the velocities after collision with velocities before collision. Anyways, both of you, everyone have written these two equations, I believe. Now I'll just divide equation 2 by equation 1. Because mass are innocuous, mass are harmless, they won't cause any difference, big difference. So m1 by, because not always substitution method is the wisest thing to do. Okay, you know these things, and if you have done mathematics a lot, if you have practiced a lot of mathematics, I think this one was, sorry, it was v2 minus v1. And if someone feels that he or she is weak in mathematics from the school days, there is nothing as such. Just go on practicing maths every day. The more you practice, the better you will become. Don't underestimate yourself. Don't overestimate yourself as well. Because I failed in mathematics at one point of my life. Now I am teaching physics, which is impossible without mathematics. And back that time, uh, qualifying the school final exam was a big threat for me. But I could perform well because I practiced, and I was just blessed with good teachers. Okay. So if you work hard, nothing is impossible. Okay, you have heard this dialogue many times. Anyways, so you can see it is like a square minus b square. It is like a minus b. So if I cancel them, I will get a plus b term here. Here also, if I cancel them, I would get this one. But this still doesn't fascinate me. Let me rearrange this. Bring the u terms on one side, and I'll write this term as this. Okay. So what does it tell me? It tells me that the velocity of separation after collision, that is this term, is equal to velocity of approach before collision. Obviously relative velocity, that's why a minus sign is there between the two velocities. The velocity with which they were coming closer towards each other is exactly equal to the velocity with which they are moving away from each other after the collision. That is the conclusion from this 1D case. It's a very simplistic case. You may be asked in the exam to show this thing. I proved that for 2 marks you may be asked that velocity of approach is equal to velocity of separation for 1D case. Okay, I don't think much time is left. So what I can do, uh, or you can also try at home. We can calculate the final velocities of the bodies, that is v1 and v2 in terms of u1 and u2. That can be done. Okay, how much time is left? Okay, let me begin it. How to find the final velocities. So what was equation 1? If you have equation 1, then equation 1 I can rewrite as equation 1 can be rewritten as u1 minus v1 equals m2 by m1 v2 minus u2. That is how you can write it. So v1 I can write as u1. I am changing the sides. v2 minus u2. That is one thing. But just now what we got? Just now we got that u1 minus u2 is equals to minus v1 minus v2. Just now we got it. So what is v2 from here? I mean the idea is that on the left hand side there will be v1 or v2, and on the right hand side there will be everything concerned with the situation before collision. That is only u terms will be there on the right. So v1 would be v1 minus u2. Simply just change it. It would be plus v1. So put this value here. Put this value of v2 here. Then what we will get? We will get v1 equals u1 minus m2 by m1 u1 minus u2 plus v1 minus u2. So I have to take all the v1s on one side. I just multiply. Unfortunately, nothing got cancelled. This thing I will get. Here I would get a minus 2u2, a minus minus plus. So plus 2 m2 by m1 u2 minus m2 by m1 v1. Very carefully do these calculations, okay? Because one minus and plus sign change will give you totally opposite result. So now take the v1 to the left. So what I will get if I take v1 common, I think I'm supposed to get something like this. And in the meantime, I will just do the same on the left hand side as well. Just keep in mind that u1, u2 are the variables, and velocity is the variable. M1, M2 is constant everywhere. So you have to express the constant things as if the coefficient of the velocities. See if we do this LCM, get like this. You can put the brackets wherever and whenever necessary. Brackets will always protect you from mistakes in calculation. So one thing I can feel that all the m1s are getting cancelled. If I divide this thing throughout on the left right hand side, I would get v1 is equal to m1 minus m2 m1 plus m2 u1 plus 2 m2 by m1. So you can see that the final velocity has this type of dependence on the initial velocities and obviously on the masses. Definitely mass will play a pivotal role here, isn't it? I mean, suppose you're playing the game of carom and you can see the mass of the striker and all the other, what they call it, I don't know. Those, what are those things called in carom? Circular things apart from the striker. Anyways, if those things are very heavy compared to the striker, then no matter you are giving the same velocity, but the final velocity will be different. It may be zero as well if the mass is too high. Yeah, that is in Bengali, but I don't know whether that is accepted everywhere, that term. Anyways, I think you understood what I'm trying to say. That is, mass also has some role to play. The final velocities, obviously, it will be so. And similarly, if you put this value of v1 in this equation, then you could get v2. I'm writing the result. You can try at home. And in the next class, we'll see those special cases. What happens if both the masses are equal? If m1 and m2 are equal, what will happen? What will happen if one mass is very heavy compared to other? Suppose I am uh, kicking the football and I'm trying to move the elephant with that. I mean, moving means the elephant will get pushed by the impact of the football. What will happen? Or uh, if two bodies will move and they stick to each other. Okay, let us see next day. So if anyone has any doubt, please ask. Else we'll wrap up. Yes. Yes. Any doubt, anyone? If not, then did everyone try that thing, finding the center of mass of a circular disk? And did you succeed in finding it, locating that? And that numerical problem, when the density was varying as sigma equals to a into h, did you do that? Yes, anyone? Did anyone do that problem, that triangular piece of paper or whatever the triangular shape, whose center of mass we had to find? What to make of this silence? Yeah, numerical problem which I gave. There was a triangle. I even gave that hint. You have to consider a small strip. Definitely, you will have to do. Then, if you get stuck, tell me. Yes, Nirupan, could you do that? Okay. If not, keep on trying. Next day, we'll see the solution. Provided I get evidences that most of you have tried it. So, I don't think you have any doubt. So, shall we wrap up? Okay, thank you, everyone. Next class has begun, I think. Okay, thanks. No problem, Nirupan. If you take help from internet, it's not an issue. You tried, that is the biggest thing. If not internet, you need to try, you need to take help from books. It's okay, no problem. I'll see that next day. Thank you.
Okay, sir.
Okay.